We are working on project 15.
Okay.
That's what we're working on now.
Hi, good evening. I just have a question for Darey. Can can you hear me, please?
Yes. Hi, I can hear you.
Okay. I'm actually part of the Masterclass D, so this is my first time of joining this like class actually. But I've completed projects 1 to 12, but I've submitted to 9. So I don't know. Does this class actually for the Masterclass, which is going to start from the beginning of the project, or how does it run? So I want to get a clarity on that. Thank you.
No. So this class takes it from project 15 onward.
Okay. 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 Is it every weekend? I wanted to join yesterday, but I dozed off actually because of my busy schedule. So
Okay. Okay. Yeah. So the way this class is going to work is so it's gonna be every weekend. However, there are some weekends that we will have break on purpose. So the reason for the break is required for you to do some work so that by the time you finish that work, then we reconvene again to continue. So let's say, for example, after this particular weekend, assuming we're going to have a break, that break is to give you time to complete certain courses. So next weekend, we won't meet because you wouldn't have completed it by then. You need more time. So it could be the weekend after next that we'll meet again to then carry on with the project. So if there's going to be any break like that, I will let you know, right? But for now, we're going to be having the session this weekend, next weekend as well. I think with the third week as well. So from the fourth week, I'll send the schedule of the calendar with you anyway. But you at least know the period where there will be a break. But it's not a break to go away. It's actually a break to allow you to fulfill some requirements, and then we'll come back again. So that's how the program is structured.
okay, all right, thank you. What about if like yesterday I wasn't part of the class? Will I be able to get the recording so I can listen to that?
Yes. Yes, you will. So after tonight's session, I'm going to send out the recording both for tonight and yesterday.
All right, thanks for the clarity. I appreciate it.
No problem.
Hi, Darey. Good evening.
Hello.
My name is Samuel.
Hi, Samuel.
Okay, sir. So, thanks for that clarity. But before I exit the stuff, I just want to raise maybe you could help out with this. I requested for something. My induction was last week. Just started the master class, and my induction was last week.
Okay.
So, because of we are working, because the value program like this for our promotion and the rest of that. So I requested for something. I requested for a letter, a proper offer letter capturing the cost implication of this program
Okay.
on the 7th of August. And I've been getting feedback. I sent a mail to the support and I got feedback that they'll revert immediately. And it has been stories upon stories. I don't really know what the issue is.
Okay. So you need a letter that's
A proper offer letter for this course, the master class, possibly capturing the cost implication of the program. I'll need that for my promotion after the program.
okay. What I would say is, why don't you send me a message on Slack? Okay, send me
Okay.
because I need to understand the the context of this offer letter. I think the confusion there is the offer that is there, so we understand the
No, when I
exact.
joined the course, I was just given an email confirmation of payment
Hmm.
after my first installmental payment, and that was all.
Okay, so would that not be sufficient, like an invoice or something like that? Would that not be sufficient
I
to?
think that's basically an invoice. I was expecting maybe a proper letter accepting me into the program, something like that.
No, we don't.
Like,
I mean, we don't give such letters, but if you need specifically for a purpose, I mean, we can definitely make that available for you. But it's not, a standard process to give you an
yeah,
offer. You understand?
okay,
Yeah. I
good.
sorry. Thank you. I Samuel.
Yeah, good deal, sir.
Yeah. Good evening. So I can confirm now that your letter, the draft of your letter is ready. So Darey is not aware yet. So it will be approved by Darey, and you will get it this week.
Okay, thank you so much. Appreciate it.
Yeah. Thanks.
All right. Thanks for that, Solomon. Okay, so I'd say probably we'll wait for another 5 minutes and then we can kick off today's lesson.
Hello, everyone. Are we having a class today?
Yes, we are, Emeka. We're just waiting for another maybe 1 or 2 minutes just to give more people the chance to join so we can start. Okay.
Okay, all right. Thank you.
Thanks. All right, guys. I'm just going to put on my camera now and we can get started. I can see 2 more people has just joined. Okay. How are you guys doing? I hope you can see me clearly and hear me as well. I hope my microphone is working very well. And I'm going to put on the recording now.
Recording in progress.
Hi, everyone. Happy weekend. Today is the end of our first weekend in September. And I hope we have Arsenal fans on here as well. I just want to say congratulations to you guys if you are a Man U fan. Okay, so we're going to be carrying on with our session today. Continuing from where we stopped yesterday. So yesterday, we started building our infrastructure. And as you know, what we intend to do is to manually build the entire infrastructure out and see that the business requirement is actually being fulfilled, which is to go to multiple websites and then have everything returned back to us from the same infrastructure. Okay. So we didn't get to complete the design. So we'll try to complete the design today, and then we'll try to start the implementation today as well. We won't be able to finish it today, but the good thing is I have a number of videos that I will share with you immediately after tonight's session that you can watch during the week that actually shows the end-to-end completion of the whole infrastructure. So if you get the chance to complete watching that video this week, that would be fantastic. If we can get everyone to do that before we meet again next weekend, it will increase our speed. But if not, then we'll have to do it in class. And then another thing is it will help you to have some questions before we meet again, because I'd expect you to have some attempts at the whole implementation and then come back to class with some questions and then we can discuss the whole thing. Okay, so don't forget, if you want to send a question, feel free to do so. I will try as much as possible to use the Zoom chat, but if you send it on Slack, it's a lot faster for me, or whichever the case is. Okay. I'm just reading Adebola's message. Yes, feel free to stay in the sessions and just keep going on until you get to the point where you're going to be falling off. So I hope that doesn't happen to you, but we'll see. All right. Let me share my screen. Okay. Just trying to drag this in. Anyway. So remember, just a bit of a recap. Let me drag this other diagram here. So this is a bit of a recap, but this is what we're trying to design. So we're trying to design an infrastructure. We have our DevOps engineers or app developers would require physical SSH access onto the servers. So the route to do that will be to have a Bastion server, and then they can hop onto the other servers within the private infrastructure. And of course, our customers, whether they want to go to tooling.darey.io or they want to go to darey.io, whichever the case, they go through this load balancer and then they just navigate through load balancer and then hit the proxy and then go to the internal load balancer, hit the respective applications, and each of those applications are able to pull data from the database. Okay, so this is here. Oops, okay. Anyway, I was going to drag this EFS, and I'm sure you know the reason why EFS shouldn't be here. And this is a potential interview question, because you might be asked things like, what will happen if you deploy EFS in a different subnet that your application is running? What's going to happen? Maybe we should even do that as a quick test. So does anybody want to give it a go? If we have this kind of infrastructure, we have EFS here and your applications are here, are they going to be able to have mount points to this EFS? Is this going to be a yes or a no? Anybody want to try? Okay, someone thinks my audio is low. I think probably because I'm far away from my mic. Is it any better now? Is my audio bad or good? It's much better. Okay. All right, cool. I guess it's because my mic was a little far away. All right. Anybody want to try it? Is this going to work, having EFS here? You're going to mute yourself. Let's have it a bit more interactive today. And it will be going forward because I'm going to be taking you back to ask a few questions as we go, just to test that you're with me. So we discussed this yesterday. Okay. EFS, I believe you all know what EFS is. In case you don't know, it's a managed service provided by Amazon to handle NFS. So if you have been working with NFS in your earlier projects, it's just a service from Amazon that takes away the whole installation of NFS and its client. Okay. Nobody wants to try. Okay. All right. So what's going to happen is this is not going to work because EFS is expected to be in the same subnet with the applications that requires to have it mounted. So Calista says it should work since it can also access the database, but I know that you said yesterday that the NFS needs to be in the, okay, guess you didn't complain, speed typing in the subnet, yeah. So technically, I mean, this should be an ideal design to separate your data from the applications, but it's just the way Amazon works. So your EFS has to be in the same subnet that your applications that intend to mount them will be. Okay, so if you try that, put it in a different subnet, try to mount it, you have errors. Okay, and then you can try the other way around and then you'll see it will work. All right. So let's carry on. So that was just a quick recap, just to bring you up to speed with what we're trying to design. So this is where we stopped yesterday. Our infrastructure is not yet complete. So what we're going to do today, let me just move this to the side a little bit. Okay. So what we're going to be doing is to see the next thing we're going to do. So what I think I'll do is let's draw the arrow. Okay. So this guy is going to talk here. What we need it to do is to be able to hit a load balancer, right? So what we can do is let's just put something here. Let's say, for example, it needs to go to tooling.darey.io. So that's one application that this customer might want to access. And he might also want to access another web, which could be maybe the main website at the time. All right. So there are two different websites. Okay, so one is going to be running WordPress. So assuming our website is based on WordPress. So that will be the darey one. And then the other one is a PHP application that has its code and all that. All right. And then we will need a load balancer. Okay. So we can deploy an application load balancer. Public ALB. So I have to put public there so that you know that it's one that is facing the public. Okay. What happened to our arrow? Okay. Now, there's something that has to be in between, and that will be DNS. Okay. So I'll just say DNS because we have to ensure that there's a DNS that resolves this domain to the address of this load balancer. Because the load balancer is going to have its own address. It could be a DNS name, usually a long name. You know, when you spin up an EC2 instance, Amazon would give you, I think I have a management console open, so I can quickly show you that. Okay, so let's go into the instances one. Why is Amazon slow today? My network. Okay. All right. So let's say, let's take this instance, for example. Okay. Now, you notice that here it says public IPv4 DNS. So some of the resources that gets created in AWS, they have an IP address and also a DNS. So let's park the load balancer for a second. This is an EC2 instance, a server. So you can either connect to this server using the public IPv4 address, which is the IP address, or you can connect to it using this DNS. So this DNS is very long, but it's as good as the DNS we're talking about. This could have been darey.io, but this is automatically generated for you by AWS when you spin up your EC2 instance. So this is a name, technically, the human readable name that we're talking about. Although this doesn't look like it's human readable because it's long, it still has numbers and all that, but it's the same thing as if we had used a human readable name because it's a record that points to an IP address. All right. So the reason I'm showing you this is when you provision the load balancer has the same thing. It can it will have both the IP address and a DNS. So it will have its own DNS. So in the case of our architecture, what we will do in this case is to point our own human readable domain to the DNS that AWS has provided. And why would you want to point it to the DNS rather than an IP address? The reason is because the load balancer itself is a load balancer, and it's think of it as having Nginx load balancer as a service. Okay, so Amazon has created a service for you that does what Nginx would do if you were to have configured it by yourself to do load balancing. But you don't have to install Nginx, you don't have to do any of those. Amazon basically just with a click of a button makes it available for you. So what happens is Amazon takes care of servers running a load balancing, okay? And you don't know, it could be 2 servers, it could be 3, it could be 4, it could be 10, it could be whatever. So we don't know all the IP addresses behind that load balancer. So it only makes sense to point to a DNS that will resolve to those IP addresses, but we don't have to take care of or think about it. Amazon takes care of it. So we point our own DNS to Amazon's DNS for the load balancer. And then the load balancer from Amazon's side just point it to whatever server is running the load balancing application, the server that's running it, which will be the IP addresses. I hope that is clear. I hope it's not too confusing. So basically what's happening is we're just going to take our directory or tooling directory or whatever domain that we want available on this. We're just going to point it to the address of this load balancer. That's all we're doing. But we're not pointing it to the IP address, because what if there were 10 load balancers, servers behind the load balancer? We're not going to be pointing it to one IP address or multiple IP addresses. It just makes sense to point it to the DNS that takes care of that. Okay. All right. So now that we have this taken care of, all our customer needs to do is just point this in the browser, point that in the browser, and the browser just does its own routine and discovers this load balancer because we've configured that. And then it goes here. So what is this load balancer now going to do? So what it's going to do is to now, what we want it to do is to talk to this proxy server, right? So if let me see, if I take an arrow, why is this arrow? Okay, so if I do something like this, for example, okay, this will work, no doubt, because it's going to take the traffic that's coming through and then push it straight to this Nginx server, and we have done Nginx configuration there to do the load balancing, or to do the reverse proxy rather, because what we're using this for in this case is reverse proxy. Okay. But whatever decision we try to do, if we just put another load balancer here and push it there, it will still work. But what I want to bring out here is the fact that if we do this, we still have a single point of failure on the proxy, because if this Nginx server goes down, the whole thing will fall apart, because yes, your load balancer is working, is available, but it's only talking to one Nginx server. And we're not even making use of the whole availability thing, because remember, the only reason why we spin up a second availability zone is so that we can spread the load and we can always fail over to another one in a different AZ. So this doesn't make sense. So I'm going to remove this. And what we'll do is, let me bring this. We're going to put this in an auto-scaling group. Okay, so this our engineer is going to be in an auto-scaling group. And what auto-scaling group does is it's a functionality in AWS that ensures that if we need to dynamically scale our servers horizontally, we can do that. Okay. Now, why would we want to scale horizontally? because you can either scale horizontally or vertically. So vertically is when you add more RAM, CPU, and things like that to your server. Let's say you're servicing 100 customers, you have 2 gig of RAM and maybe 2 virtual CPUs, okay? And that works fine. And then your request increases to about maybe 100,000 customers. Obviously, 2 gig of RAM is no longer going to be sufficient. So you would then need to add more RAM. So you can add maybe change the server configuration to have maybe 8 gig of RAM this time around. But are you going to keep doing that when there's new growth? What if we grow to 100 million customers? There is a limit to which you can increase or scale a server to vertically. So you will always come back to the same problem, and it doesn't make sense. So this is where distributed computing comes in. So distributed computing is more about being able to scale the infrastructure horizontally. And what that means is adding more servers to your infrastructure. So if you had one server, 2 gig of RAM, 2 virtual CPUs, if there's need for more capacity, you add another server. Automatically, you have 4 gig of RAM and 4 virtual CPUs, right? Because you've added another. The good thing with that is you can continue scaling and there is no limit to where you can reach. So I can see Eric just sent a message. Easier to scale up and down in horizontal way, max limit and noise. Okay, yeah, thank you. So you're just buttressing what I'm saying. So that's the reason why you would want to continue doing horizontal scaling. So there is a functionality in Amazon that allows this scaling to happen dynamically, and it's called the auto scaling group. So with auto scaling group, you can scale in. So scale in is to reduce the capacity. Scale out is to increase the capacity. And it works automatically because you don't have to set up monitoring and receive a lot and say, oh, our user base has increased. We need more CPU. We need more RAM. And then you wake up in the middle of the night, you go onto your infrastructure, and then you say, oh, increase the count to this and that. No, it works automatically based on the configuration that you set. You can say when CPU usage has reached 70% or 80%, at that point, please increase my capacity by 1 more server or by 2 more servers. And immediately the server, Amazon will spin up more EC2 instances. So you had one EC2 instance before servicing maybe 100 customers. Now you need to service about maybe 1,000 more customers. Auto scaling group increases the load, the capacity, and adds more servers to it as you have configured it. Now that is scale up. But what if maybe during weekend, no one really use your website or some of your services do not require as much capacity? You don't want to leave your servers running and you're spending money on cloud cost. You're able to automatically scale in as well. So you can set the configuration to say when the capacity of your CPU or RAM has reduced to a certain threshold, then terminate the instances, the extra instances that's been created, so that we come back to 1 or 2. So that way it takes care of scaling. So that's the reason why we need to put these servers, each of our servers, both the proxy, the WordPress, the tooling app, all the whatever servers that we need, we have to put them all in auto scaling group to have that functionality. Okay. So let's see what that's going to look like. Let's bring to front. I hope it's to front. I don't think it is. Is it bring forward? Oops, no. Let's try again. To front. No. Okay, let me see. Maybe it's even to phone. I don't know, but let's. I think there's something opacity. I think it's right here. Where is it? Back. Oh, they wanted me to send it to back. But now that it's to back, I'm not able to drag it. Okay, so let me put it here. It needs to go to back. And then let me give it a color. This is the challenge. Okay, so let me put the color from here before I send it in there. Okay, good. And then I want to reduce the opacity. Does anybody see? Okay, yeah, I see opacity here. Okay, good. All right, cool. So that's what I want to do. Let me enlarge it a little bit, maybe here. And then I can spread that. So that's what I wanted to achieve. Okay. Probably reduce the opacity further. All right. Okay. So what this means is now we have auto scaling group to mean that if we need to scale out, scale in, it can go across the two availability zones. Okay. So it's possible we start out with one server or maybe two servers. If you start out with two servers, one is going to be in this availability zone and the other one is going to be here. If we increase the capacity with two, another two, it will spin up one here, another one here. So when the traffic is coming, what will now happen is it's basically talks to this auto scaling group. Okay. I hope this is clear so far. All right. Now, this is where a bit of confusion may start creeping in, but don't worry, you will not be confused because I'm going to ensure that I explain it very well. Now, the way autoscaling works is there's something called target groups, right? These target groups is how, because you can imagine if the traffic is coming down, right? Each of the services or servers here, they have their IP addresses. So how then is the load balancer going to know, should I point it to this server here or this server here? I mean, they're going to have their respective IP addresses. So how will it know which one is going to send the traffic to? Actually, let me quickly put it here. Auto scaling group. How do we? Okay, just ASG. Okay, just put that there to say ASG, so we know that's an auto scaling group. Now, this auto scaling group, think of it as it's just a container that holds, those servers for scaling. But for it to work, there's something called the target group, which helps the load balancer to know which group of servers should I send the traffic to. Because when it comes to this auto scaling group, it just needs to be able to know who it's sending traffic to. And when we start configuring it in AWS, it will make a lot more sense to you, but just conceptually know that there is something called the target groups where you will then begin to put those servers in there. All right. So let's say I bring up this and then I call this target groups. Okay. And let's reduce this. And then have it talk to the target. So the target groups here is going to be for Nginx. All right. Okay, cool. So we have a load balancer. It sends the traffic to the target groups for Nginx, which is part of this auto scaling group. But there's another thing as well, which is there is one more thing called the listener, because you have to configure the load balancer to listen on a protocol and port. So in this case, we can then put a listener here, and the listener is going to be based on HTTP, HTTPS. Okay. So you know that when you go to your browser, I mean, you can tell this is HTTPS. That's the protocol that is used on web, right? So we have to let it know that it has to listen on port 80 or port 443. So HTTP is port 80, which means it is not secure. HTTPS is 443 port. Maybe I should even write it here. So 80 and 443. Okay. All right. So these two ports will be configured on this load balancer to ensure that when it's sending the traffic, it's going to be based on this port, and it sends it to the target group, and then the auto scaling group. The servers part of the auto scaling group will be the ones that will receive the message or the traffic or the data, basically. All right, so that is how we're going to be able to send traffic all the way to Nginx. So we could have sent it directly to the server, but that will still leave us with a single point of failure. So to solve that problem, it has to be done as part of an auto-scaling group. And for the auto-scaling group to work, we have to configure the target groups, which the Nginx will be part of the target group, and that will be attached to this auto-scaling group. And then the load balancer itself will be configured to listen on certain ports, and that way the traffic will go onward nicely. Okay. So we just hit the reverse proxy. We haven't actually reached our application. So once the traffic hits here, we can say, well, go straight to WordPress, or go straight to tooling app and whatnot, because this is a reverse proxy. It's able to have the configuration, the Nginx configuration files that we will set can be done in such a way that it sends the traffic to the respective services. But we're not going to do that. We're going to have to put a load balancer in between, which is going to be an internal load balancer. So let's just get the logo again. Why is this one looking faint? Okay. Oops. Oh, the opacity is affecting it. I think that's why. Okay. We'll bring that here rather than send the traffic directly there. So we'll just send it to this load balancer. Okay. But again, the same configuration here applies, whereby we would have a listener configured, and then it sends it through to, oops, it's now becoming a bit messy, but let's move on. Let's have the auto scaling group. Okay. Let me just remove this here first, because avoid the confusion. So this is going to be, oops. or the auto scaling group. Okay. And then we'll have this target groups. What we'll do is this time we won't put Nginx here, but it will represent target groups for each of the application. Yeah. Okay. Right. So then this load balancer will be somewhere here. Let's just make it a little small. Make it tiny. And then I do apologize. This is going to look quite messy, but that's why it's important that we design this together so you see how everything came about. Okay. All right. All right, cool. So I'm able to fit that in there. And then it goes through that. Oopsie. Let's just drag that in. Come on. Oh, somebody help me. So this is the style I'm going to adopt. I'm going to make it big a little bit. And then, oops. Okay. And then okay, cool. So now that I've dragged that, I'll make it small and then I'll bring it back. That's the strategy. Okay, and then bring this down a bit. Okay, good. So now, okay, someone wants me to zoom in. I will. I'm just trying to get this thing. Okay, so let's try again. And by the way, let me just do the zoom in for you. Okay, I hope that's okay. Yeah, I got that. So I just want to reduce this one a little bit and then bring it back down and then bring this in here. Or I could even bring it to the side like this. Maybe that would even be better. I think that would be better actually. This can be a pain. Okay, let's just, yeah, I'll just leave it like this and then take this here. Yeah. But, you know, the whole idea is all that matters. So you understand the flow of the traffic. So it comes through this, reaches Nginx, and then Nginx sends the traffic to this load balancer, sends it to the target group, respective target groups for the respective applications. So whether it's for WordPress or tooling app. So there is going to be a configuration in Nginx that will store the host header. So it's going to take the host header, and the host header basically means that it's going to put the name of the domain of where it's trying to reach. So for example, if it's trying to reach tooling.darey.io, in the HTTPS payload that gets sent forward, it's going to have a property, a host header, which will then pass along. So that host header information will be sent to Nginx, and that's how Nginx is going to know that, oh, it needs to talk to tooling.darey.io, and then it sends that to this load balancer, and that load balancer also takes that information, and then it knows where to send the traffic to. So when we start doing the hands-on implementation, you will see how all of that works. Yes. So what I don't want to do is to start creating more space, GD, because unless I lock the whole thing like this, let me see if I lock it. Because if I try to start creating space, it will just mess the whole thing up. Do you get what I mean? So that's why I'm trying to avoid having to do that. But anyway, the whole thing, we're there anyway. So then we can then get, actually, no, not that. Each of these applications can then talk to their respective database. Okay. Okay, I'll just leave that as it is. So let me zoom this. Does anybody have any questions so far? So I think we're there.
Yes, I have a question.
Yes. Go
So
ahead.
my question is the auto-scaling group for the applications, the
Yes.
services. I think we should have an auto-scaling group for each of the services, because in a scenario where we want to scale by 3, like have 3 replicas of our service, we might be having like 1 tooling, 1 WordPress, and maybe it will not be complete because your application, the service inside the auto-scaling group are actually not the same services. They are different.
Okay, so John, so that we don't confuse each other, that's exactly what's going on there. Maybe the diagram is just not doing enough justice. So each of them have their own auto-scaling group. So as you can see, Nginx
Okay, yes,
has its own auto-scaling group. But just because of the way the diagram is, ideally, what this is representing is the fact that WordPress is in its own auto-scaling, tooling app is in its own auto-scaling. I mean, we could as well just do something like this. Okay.
Okay, that's fine, that's fine.
Yeah, but just so to show that this target group, okay, is sending traffic to the respective applications. All right, so that's the reason why I put the target group here, and to also help you to understand that auto scaling works with the target group. Okay, so but thanks for pointing that out, because that means it could confuse other people. But for the sake of everyone else, each of these applications have their own auto scaling groups. So when we start configuring in the console, you see that in action. Okay, and that's why it's important for us to design together like this, because looking at this diagram may be a bit confusing, but the purpose of what we're doing is for you guys to understand the logic behind this, and we design it together. Okay, so if you have any confusion here, just as John has done, please feel free to raise it so that we can clarify. But again, the auto scaling is for each of the applications. Okay. All right. Does anybody else have any other question?
Yes, sir.
Okay.
Lisa, from the diagram, can you
Yeah.
throw more light on the listener? Because I think the listener should be configured inside the load balancer, right?
Yes.
And for me, I don't know. For me, it seems that from the diagram, if the labeling of the listener comes after the load balancer, I think it's like it's not more configured inside the load balancer. I think it should be in front of it.
Like
Something.
somewhere here.
Yep, yep. I don't know how. What is
Yeah.
my thought is
Yeah.
okay.
You're right. I'm even glad you're raising that because it shows you're following. So, but basically, we can actually do what you've just said to say, okay, the listener is here. All right. Yeah, absolutely. You're right. Because, the listener is configured as part of the load balancer. If we even put it on top of here, it may even make a bit more sense. Okay. But like I said, this is more of ensuring that you understand exactly how this works so that when we start implementing it in the console, you would always remember the flow of everything and it will make more sense to you. Because if we start implementing, I was just clicking, configuring, you will get lost, trust me. But with this, it will be easy for you to remember. So thanks a lot for that. Okay. And I think one thing that we can do, I want to try to share this. Let's see. I don't get to see the diagrams.net's, what's it called? The whole thing anymore. Okay, this is what I'm looking for. But for some reason, it's gone to the side. Let me see if I refresh this page. I'll see it again. I want to send this link to you so that you guys can also keep it handy. Okay, there we go. So let me see if I can share this. Why is it taking time? Okay, anyway, let's not allow this to take our time. Okay, let's see. All right. So, and then I just put one more thing here, this arrow sending traffic from here to there. So basically what this is doing is it's sending data. So anytime maybe WordPress writes data into this database, which is the right instance, sends a replica of the data to this database right here, which is the read replica. So we're not going to have a multi-read, a multi-write database because there can be data inconsistency. So what we're going to do is to have one that is a write, read and write instance, and this sends data here. Now, any of these applications can read from the database, okay? But if there is need to make this become a write, it's possible. So the whole thing switches around. So this becomes a write, and then this becomes a read. But if the whole AZ goes down, this can be configured to become a write instance, and then all the databases can start writing here. Okay. So one read database. So both are read, so they can both read from both AZs. Okay. So this is read and write. This is read only. Okay. So say for example, it's intelligence to know if a request is for read. So it can either send the traffic here to read or send it here to read. Or if it's for write, it would only send it to this place, right? But because Amazon takes care of the multi-AZ situation for us, we don't have to worry about how the replication goes and things like that. So Amazon takes care of it. Okay. All right. So I guess we can start our implementation here with all of this set up. All we just then need to do is to go into each of the servers and then install our application there, update the server, do whatever we have to do. Once all of this is configured, we can go to our browser and everything will just work fine. It will load the pages. So the whole traffic will just flow through and all the way like that, and we'll be fine. Okay. All right. So the first thing we're going to do in terms of implementation. So I have my notes. So there's a note that I've written here that will guide us with the implementation. So let me drag that over. All right. So with this, it's our implementation guide. It's the same thing that's in Project 15, but if you want this note, I can also share it as well. So basically, we could just go step by step. Number one, create a VPC, subnet, internet gateway, routes. We go step by step and what we need to do to configure our Nginx, and keep going with all the configuration. We'll keep going with all the other configuration. We have to configure security groups and all that, and all the way to the end. So this is what's all that we're going to be doing to configure this infrastructure. So what I will do is, let me just copy this. I'll share it in Slack.
Sorry, please, I have a question.
Yeah.
All
Go
right,
ahead.
please. The question I was trying to ask was, since both AZs are being used at the same time, right?
Yes.
Yeah, so if one AZ is writing into that database, so for the second AZ, is he writing also into that database, or the second database is just a failover?
Yeah. So so I've mentioned it earlier. So this is not doing any writes. This is the only one that is doing write. Okay.
Okay.
So this is a read-only replica. So it's just sending data here. Okay.
Okay. That's just one database for the two AZs. All right.
Yeah. So it's a database as a service. All right. So you just create an instance of the database, and then it will have a read replica in the other AZ. Okay. And then you would only go here to write data. Sounds good?
All right, good. Yeah, so that means all the instances across both AZs are writing to that single database.
Yes.
Okay.
Yes.
Because the arrow was just from one AZ to that database, so I was only about the
Yes.
second.
Okay, yeah. So it's basically just because of the way our, what's it called, diagram and all that.
All right,
so
good.
That's
okay, thank you.
Right. Okay. And let's say read replica. So it's replicating data across, something like that.
All right, good. Thank you.
All right. All right. So in the general chat, I'm going to send this there. Okay. So that you guys can follow along with me as we're going. All right. So, okay. So let's go into, I'm sure you're familiar with AWS. So in the search there, you can just type VPC. So we're going to start with VPC. So we're going to create a VPC, and then we'll start our configuration. All right. So the first thing we're going to do is to create a VPC. So you have the option to create VPC and a few other things. Quite a number of things have changed. They are constantly updating things here. But what I would recommend is, first of all, create VPC only. Okay, because if you do VPC and more, it means you want to configure your subnets and decide on your AZ and things like that in one shot. So I would recommend you start with VPC only, and then we'll take it one step at a time, and then we'll go back to create the subnet and hook them up with the VPC and do all that. So we can name our VPC, let's say MCD, meaning Masterclass D. Okay, Masterclass D. I believe this is Masterclass D, right? And in our diagram, the VPC CIDR is 10.0.0/16. Okay, so that's what we need to do here. All right. And it's very important to always tag the resources that you create in AWS. So this is from a real world perspective now. If you don't tag it, you'll end up having an infrastructure that has so many resources that you can't really search to filter things. So say, for example, this infrastructure, we're building it for departments in the organization. So you can have a tag to say departments, if you're developing this or building this infrastructure for maybe the finance team. And then if there is a billing ID that your organization uses to separate which account the cloud cost comes out from. So they can have different billing IDs. So you can have billing ID. And if your company has given you a certain ID, so let's say, for example, this is your billing ID, you have to put it in. So the reason for all this tagging is just to ensure that when we want to run a report, we can filter by things like this. These are labels, okay? Or if you have a lot of servers and you want to find out which servers belong to the finance department, you can just run a report that easily filters that out. And imagine if there was no labeling like this, it would be hard to figure things out. You can even have servers that will continue running and you won't even know they exist there. And every month you're receiving costs, so it's very important to have this as a practice, okay? And then this name tag is very important because this is how in the console you will be able to see the name of the resource. Because sometimes you can create a resource, but it won't have a name, okay? So if you put a name like this, you give it a name, MCD, you see that in action very soon. So let's just create this VPC. Okay, and if I go to your VPCs, you can see that's the name tag is what made it to have this name right here. Okay, so if we input it, so these are the tags that we created. All right, so very important. Okay, so the next thing we want to do is to create subnets. So if you're following the notes that I shared in Slack right now, you'll be able to follow along with me. So on number 2, what we want to do is create subnets. So we can go to subnets and then hit on the create subnets button. So in which VPC do we want to create this subnet? So in MCD, which is the one that we've just created. All right. So you can add more and more and more subnets. So according to our diagram, we need 1, 2, 3, 4, 5, 6, 7, 8 subnets. So we're going to create 8 subnets. So this is 1, 2, 3, 4, 5, 6, 7, 8, right? So we can start populating each of them from the top. So you can imagine when we start automating this process in code, we don't have to click on buttons and all that. We just write some code, run the infrastructure, and it will just create everything, which is part of the things to think about when we are designing an infrastructure. So the next time we meet, before we continue the implementation, I will talk about the 6 pillars of infrastructure design quickly so that we then begin to see reasons why we're making certain decisions, why we're separating networks, why we're doing all those kind of things. All right, so the first subnet, we can call it our public one. So this is going to be our public subnet, MCD. Okay, so I'm just randomly giving it a name, so it's not like it has to be anything particularly. It depends on the naming convention that you're using in your organization. Okay. All right, so we have two availability zones. Okay, so it's identify that we are in the EU West region. So there are 3 available ASINs in this region. So we have EU West 2A, 2B, and 2C. So we have a design that requires just 2 of them. So we're just going to stick with 2A and B. So we'll put this in 2A, okay, and then we'll give it the CIDR. So the CIDR for this one, this is the one we're creating now. So that's 10.0.10/24. Okay, so we can say 10.0.1.0/24. Okay, so that's the CIDR for this subnet. All right, and you can see just by specifying this subnet name, it's already created a name tag for us. So Amazon also understands that this name tag is very, very important. Okay, so we're going to do the same thing for everything. So one thing you would notice is this. So this is public 2. You notice that, well, even though we are designing for public and private subnets, we're actually going to be creating all the subnets exactly the same way. So the fact that we name this public does not mean that automatically it has become a public subnet. So by default, when you're creating subnets, they are private subnets by default. All right. So this is going to be in 2B. So we already have one in 2A. So we're creating the second one in 2B. And then the CIDR for this one will be 2. Okay. And the name tag is populated. So the same thing is what we're going to do for the rest. So this is going to be actually we're going to public 2. So this is going to be private 1, MCD. Okay. And this is 2A. And this will be 3. Is it making sense to you guys? And then the next one is going to be private 2. And then we'll put that in the second AZ. Okay. And this will be 4. Okay. So far we've created this and that, created this and that as well. So 10.0.04 is that correct? Yeah. Okay. So you see what I mean? That even though we name this private and this one we name it public, we're actually creating them exactly the same way. So for now, they're all private. So remember this, they're all private right now. Okay, it is after we've created the subnets that we will then do extra configuration to make this become a public subnet. Okay, so forget about the fact that we're giving them names. It's just for us to be able to identify what we're doing. Okay, so they're created exactly the same right now. So let's create the 5th one. So this is private 2. This is going to be private 3. Private 3. Okay. 5. And this will be into A. It's one of those things you want to take your time to create so that you don't make mistakes. You proofread them again and again. So this is the other one to say this is P, K, and then hash 4, 5. Okay, and then 6. All right, so we've created everything. But I'm thinking, should we, so this is data layer. I'm thinking to put the actual name of the subnets, I mean, the purpose of the subnet, so that we can easily identify. So this is the data layer. Okay. And then this one is for the compute. And then compute as well. And this is for the proxy. All right. And this is public. So it's just public. So I think that this way, it just makes it visible and easy to identify the purpose of what we're doing. So now it all depends on how you want to, because some organizations will have their naming convention for things. Okay, so you follow whatever naming convention is used. So let's create it. So if we click on this, it's going to create all the subnets. And now we can see all the subnets that's been created for us. Okay, so because of the name tag, we can see all the names nicely written out there. And they're all part of this MCD VPC. So which means all this is part of this private network. Okay, so that's been taken care of now. So the next thing we want to do is to create the internet gateway. So the internet gateway is so there's internet gateway here on the left. So it is that thing that makes it possible for our infrastructure to be accessible over the internet. So we can name this MCDIGW. So that's internet gateway. And then of course the name tag is there. So each of the resources should have the relevant tags. So there are default tags, like the billing ID, the department, things like that, make sure it's always there when you're doing that for your company or whoever you're deploying this for. So this is just a click of a button to create the internet gateway. And so the states has to change when it's ready. It will take a bit of time, but once it's ready, we then need to attach it to a VPC. Okay, so let's see. So this is wait a minute. This is our internet gateway right here. So we need to attach it to the VPC. So that's basically what we're going to do. Okay, so let's say attach to VPC. So you can select the VPC MCD. All right, and then we can attach into the gateway. So now it's attached. And this way we have an infrastructure that is accessible from the internet, but to begin to deploy services such that for over the internet we can access it, we need to ensure that we configure a subnet that can be accessed over the internet through the internet gateway. And that's where the root table is going to come from. Okay. All right. So what we're going to do is we're going to go to the root tables. Okay. So create a root table. So we can name it MCD root table, RTB for root table. And then we select the VPC that this root table is going to be part of. Okay. And that's it. So creating a root table just means we're creating a table, a container that will not have entries. It's just like opening up a spreadsheet and it doesn't have anything. So you can now start creating tabs and start putting records in there, right? Which is what we're going to do. So we're on, actually, so I just made an update to my notes, which wasn't there before. So what I'm going to do is I'm going to quickly update that in the message I sent on Slack so that we're all on the same page. Okay. All right. So if you follow the note, I am now on number 5. So I've just added number 4 to it, which is attach the IGW to the VPC. It wasn't there before. So create a root table for the public subnets to use. So we've just done that. Create a root in the public root table and point it to the internet gateway. So what we need to do is to create a root. So how do we do that? Edit roots in the table. Okay, and what we're going to do is we select everything. So internet gateway, select this internet gateway and save. So we've made an entry to say all the traffic should go through the internet gateway. So in this table, we have this entry right now. Okay, so the internet gateway is the route to and from the internet. Okay, so the next thing we now want to do is to associate the public subnets to the created route table. So there is a tab here that says subnet associations. So right now there is no subnet that is associated to this table. So if we edit this subnet association and we select which subnet we want to have that association. So we can select the public 1 MCD and public 2 MCD and save. This is now what makes those subnets public subnets, because now there's a route to and from the internet through the internet gateway that makes that possible. And that's now what's happening. So if we now deploy any server in this public subnet, you can access that server over the internet. But if we did do what we've just done and you deploy any server there, that server will not have a public IP and you won't be able to reach it over the internet. And same way, no one will be able to reach it over the internet. Okay. So that's for number 7. Now, number 8 says to create a NAT gateway so that servers in the private subnet can reach the internet to, for example, download stuff. Okay, so we're going to talk a bit more about the NAT gateway shortly, but let's create it first of all. So where is NAT gateway? So we have NAT gateways here. All right, so we create a NAT gateway and then we give it a name. It's a MCD NAT GW. Okay. And then we have to select which subnet we want this NAT gateway to use. So we are going to select our private subnets. So we'll talk about those. We'll talk about the private, sorry, NAT gateway shortly. So let's select our, so like the proxy, for example. Okay, so what we'll do is actually we'll select one. We can update it later on. Okay. So we need to allocate an elastic IP. So we've just done that. So basically, when we start talking about NAT gateway, we'll talk more about this shortly. So let's get back. So let's have a look at the that again. All right. Okay, so this NAT gateway actually, this should be created in the public subnets. So it was a good thing I had a quick reader on the description again. So this has to be in the public subnets. We'll talk about that shortly. Let's select our, let me say MCD public one MCD. That's so we want it to be in the public subnet. Okay, let's create that. So this will take a bit of time for it to be ready. So let's go back to our diagram. All right, and let me see if we have maps. Okay, so VPC NAT gateway. So this is what we've just done. So we didn't consider this initially during our design, but we've just done this. And let's actually, let me bring the other diagram. Right, okay. So this is the, let me see if I can just copy this and paste it here. Okay, cool. All right, so I can send you back. All right, there we go. So remember we created the internet gateway, and the internet gateway's job is to, okay, yeah, so Akiwale, yeah, thank you for that. You've just mentioned that the NAT gateway should be in the two public subnets for the private subnet to use. So yes, so I'll talk about that as well shortly. All right, so now the internet gateway that we created is so that people from the internet can actually have route into our infrastructure over the internet. So it's more of an inbound thing. Okay. Now, when we have servers running inside a private subnet, Nginx, WordPress, we deploy our Ubuntu, Red Hat, and whatnot. These servers, they need to be able to install packages. Okay, you want to install Nginx, you do sudo apt install, or you want to update the repository, apt cache, and all those things. They need to access the internet to pull the files that will be downloaded, right? But because they're in a private subnet, there is no way to reach the internet. So there are a number of options to solve that problem. One of those options is to deploy a NAT gateway into a public subnet so that there will then be a root table similar to what we created for the internet gateway. So we'll have a root table that then has the routing information of how to reach the internet through, let me just draw the arrow, through the NAT gateway. right? So that means if we then do sudo apt update or apt install or yum install or any of those commands, it will be able to go through this NAT gateway, which does network address translation, such that it can go over to the internet, and whatever endpoints that is hitting is able to see the IP address of that NAT gateway. So that when it's sending data back, it sends it back to the NAT gateway. Okay, so all the files that you're trying to download, those packets will reach the NAT gateway, and then the NAT gateway can take care of sending it back to the calling server. So the endpoint outside does not actually see the IP address of this Nginx or any of the servers in the private network. It's seeing the IP address, thinking that the request is coming from this NAT gateway. So that's why we had to allocate an elastic IP address when we were creating that gateway. And to answer your question, actually, you're correct. So for high availability's sake, we can have a second NAT gateway in the other public subnet. But the reason why sometimes you're okay with one in this subnet, even though, yes, there is still a single point of failure, this is where our talk about SLA and how highly available you want the service to be. Because NAT gateways does cost some money, you pay money to AWS. So you may not want to run the extra cost of having a second NAT gateway here. The downside to having just one is what if ever this whole AZ goes down. Okay, that's the only time that this will not work. However, you can still use one NAT gateway and put the routes to use that one NAT gateway, which can be used by both AZs. But if you just want another level of redundancy, that's when you can then create a second NAT gateway, which you can leverage on from a high availability perspective. So I'm reading what Uzoma is saying here, that I think the NAT gateway is better on the private proxy subnet since we have the root table on that layer. Now, because the NAT gateway needs to have a public IP, you can't put it in the private subnet. It has to be in the public subnet because that's it's about being able to reach the internet, right? So if you put it in the private subnet, you're still not going to be able to reach the internet. So it's about being able to go to the internet, and that's why we have had to put it in the public subnet right there. Okay. Any questions? All right.
Yeah, I think I have. Yes, I think I have a question.
Okay. Yes, please.
Since we have the NAT gateway at the public one, how will the second availability zone access to that NAT gateway in order to communicate to the internet?
So it's going to be through the routes. So we create a routes table, okay, and in the subnet association, we can then select which subnet is going to use that routes table. And remember, the routes table will have the routing information that use this NAT gateway to reach the internet. Does that make sense?
Yeah, it makes sense.
Yeah. So that's what we're going to do now. So we're going to create another routes table. We'll configure it to use the NAT gateway, and then we will edit it for subnet association, and then we'll select the subnet that's going to use that route table. Okay. So then we can select all these subnets, and so that way they're all going to use the same NAT gateway. All right. So, but like I said, if you're happy for that extra cost, you can have another NAT gateway here, for extra redundancy and high availability, basically. But in most situations, one is fine. Yes.
Yeah, please. Now we know that we have a public and private. So put this putting access.
Sorry, your audio is breaking, and I can hardly make out what you're saying.
Can you hear me now?
Yes, it's a lot better. Yeah, I can hear you now.
Can you hear me now?
Yes, I can hear
Okay,
you.
so I was asking now that we're linking both the private and the public through one link, won't it give access?
I still couldn't make out. Do you mind saying that one more time?
Yeah, like okay, we're using one route for both the public and the private.
Are you talking about this roots table here or this roots table here? Which one?
Both of them. So we're trying to use one route. We're using one NAT gateway. That's what I mean. Like, we have a public and a private. So would that give access to the private work?
I'm struggling to really understand the question.
I think what he's asking, if you can hear me, Darey, is wouldn't having the two root tables and then specifically the root table in the private subnet give access to give access from the internet to the private subnet. So I guess he's asking why that's going to the internet when it's supposed to be in the private subnet. Yeah. I think he's trying to make up what he's saying.
Okay.
Exactly.
So if I'm going to recap that question, is to say, why are we configuring a NAT gateway to give access to the internet when we are supposed to be private, right? Is that the question?
Yeah. What he's trying to say is that he's thinking that the NAT gateway will give access to the root table to the private subnets. So the arrow is supposed to be pointing out since it's going out to the internet. That's what he wants to know. So maybe he needs an explanation on that. Yeah.
Okay. So why this arrow is pointing out? Yeah.
No, he is wondering why the NAT gateway is in the public subnet.
Okay.
And the root table is in the private subnet.
Right.
He's thinking that will cause packets or traffic to come into the private subnet, exposing the private subnet to the public.
Right. Okay.
So he needs clarity on that. He needs
Okay.
to know that the public subnet cannot access through the NAT gateway to the private subnet.
Yes.
Otherwise, it's supposed to go out. So just explain to him.
Yes.
That's what he wants to.
So basically, all we care about for this private is
exactly.
Yeah.
That's what I meant.
Okay. So all we care about here is so that we have a way in which our servers in the private subnet are still able to go out to the internet to download stuff. People from the internet cannot reach the private servers still. It is only servers in this private subnet that can go out to the internet. Okay? The reason we need that is so that we can still download things even though we're in a private subnet. So let's understand that first of all. Okay? And the only way that would work is through what is called network address translation. And what that basically does is, let me try to simulate something. So let's have this here. So let's say this is a server here. Okay, this is, let's say, our Nginx server. Okay, and this is maybe Ubuntu repository where the packages are. Okay, which is basically another server holding, different packages to download stuff from. Now, when this server wants to talk to this server to download stuff, assuming this is in a public subnet, if this was in a public subnet, all this needs to know is the IP address of this server so that when it's sending the packages back, it knows exactly where to send it to. Because it has a public network interface, it's able to send it back, all the packets will go there, and this is able to do whatever it needs to do with it. But in this case, this is in a private subnet, so it's not able to go directly. So think of the NAT gateway as a proxy. Okay, so it now goes through these, and this goes through that. So this is our gateway. Okay, so this is in a private subnet, and this is in a public subnet. Now, when this Nginx wants to download packages from this repository, it goes through the subnet, the gateway rather. This has a private network interface that even if this repository knows about that private IP address, it's never going to be able to send anything to it. Okay, so what happens is this Nginx talks to the gateway that has a public IP address. Okay, the public IP address of this gateway is what this Ubuntu is going to need to send the packet back. So this Ubuntu repository does not know of this Nginx server at all. It knows only about this gateway. And the only way this can talk to this is because this is in a public subnet. It has a public network interface. And so it takes the public IP of this, sends the packet back, and because this is in the network, the VPC, okay, it's able to talk to this Nginx. Then it takes the packet and then forwards it on here. It does a network address translation to know that this is the actual server that requested for that packet in the first place, because there could be multiple private servers, right? So it does the translation and then it sends it back to this. And that's the only reason why this has to be in the public subnet, because of the public interface that it requires to work. But no one can still get to this server even through the gateway, because this will only work, because it receives a request, it goes out to the internet and send it back. You can't talk to this and say, oh, I want to SSH into this and then get into that. Okay, so that's basically what we're saying here. So thank you, Jide. So Jide has just said something I'll read out. What is important here is that a traffic initiated from the internal network has a return path. I think that's a very, very easy way to think about it. So it has a return path. It knows exactly how to send the data back to where it came from. All right.
Right.
I hope that's clear.
And Darey, might I add that for his question that he asked about that. So part of what the root table does is it does the translation in such a way that it will, let's say, take the resource and then identify which port, and then it will also map the private IP, which is not to be broadcasted in public, and then assign. So when the gateway assigns when the NAT gateway assigns the public IP to it, it's it is mapped to the private IP, but that information of which private IP relates to which public IP is retained within the root table, which is not shared in public. So when the traffic is routing back, the NAT gateway knows which resource this information is supposed to go to.
Exactly. Thank you very much, Eric. That's exactly the explanation to that. Okay. And I know, especially when you're new to tech, you're new to IT, cloud, and all that, this whole NAT gateway, internet gateway, load balancers and target group autoscaling, those concepts can be very confusing. So it's always important to keep on having this conversation, have like multiple people say the same thing over and over and over again. And trust me, it then begins to sing, over time. And for those of you guys who are coming from network industry already, this is a piece of cake too, because this is what you do all day long already, right? So it took me a while to even understand this concept, because I didn't come from a networking background, okay? So I had to take the pain that some of you may be going through now to really understand and just try to understand and just watch different videos, listen to many people talk about the same thing over and over again. So it's normal if you're still having a bit of confusion. It's very, very normal. Okay.
I think before we go for the, you want to make it clear to me. So give me something.
Sorry, Claire, your audio is not clear.
Yeah, can you hear me clearly now?
Yeah.
All right. I think I need a bit of clarity on the NAT gateway, and I know of the NAT instances as well. So which one do you actually advise? Because I learned that okay, NAT instances actually come free, while NAT gateway is a paid version of the NAT instances.
So by all means, always use the NAT gateway, because NAT instances, you are still managing it, so it doesn't make sense to still have the overhead to manage the whole NAT translation and all that through a NAT instance. In fact, even AWS they don't even recommend that you use NAT instances. If you sit for the certification and they give you options, always select the NAT gateway, because it's managed service and it's just easy to use. Okay. I hope that makes sense. All right. So where were we? Yeah, and Uzuma has just said that instance is deprecated, so can't even use it. All right. So let's see. So we had created the NAT gateway. So that's number 8. Create NAT gateway so that servers in the private subnet can reach internet. Number 9 says create root table for the private subnet to use. So let's create a root table now. Okay, so let's refresh this and see the state of the gateway. Okay, so you can see it has a public IP. So it does have a private IP as well. It's available, it's in the public, connectivity type is public. So let's create a root table. So what do we call this? So MCD root table. So let's edit this and edit. Can we edit the name? I believe we can. Because I want to say MCD so that we can identify the public obviously. Hopefully we're still going to be able to do that. Tags, manage tags, name, MCD, public. Okay, let's see if that's okay. So that works. Okay, so root table. So now we want to create the private root table. So because the one we created before was the root table that holds the routing information on how to reach our public subnet. So the one we want to create now is the root table that the private subnet will be using, and then we can put a routing information there on how to go out to the internet should we want to download something. Actually, before we do that, let me quickly explain one more thing. So there are a couple of options that we can have, because what if the requirement says we don't want a NAT gateway, we don't want anything that does network address translation. I don't know, for whatever weird reason, we want to tighten our infrastructure such that none of our private servers can even go out to the internet. In that case, what you could do to be able to download stuff from the internet is to have another proxy here. So you can, let's say, actually, let me just copy this and paste this, and then we can say this is a public proxy, or let's say cache server, something like that. Let's say cache server. Okay. So you can have like a server here that is going to hold the files that you would ever need to download from the internet. So you have that in this public subnet, and you want to download Nginx, you want to download any application, whatever, anything you need to download, it would only be downloaded on this server. So this server will have antivirus and a few other things that does scanning and make sure that they can quarantine things. And anytime you need to download things, your apt repository will be configured to only talk to this cache server. Okay, so that way you would never have to go to the internet. You would only talk to a server internal to your infrastructure, but you are dealing with the whole virus scanning and whatnot. So it's possible for now. You should bear in mind the kind of problems that you would face with this kind of setup. If you want to download Nginx, for example, Nginx package would have certain dependencies. So that means all the dependencies you would always have to ensure they exist on the cache server. So if you want to download something for the very first time, maybe you need a networking tool to be able to scan network or to ping somewhere or whatnot. And the server doesn't have that tool. And you do yon install telnet, for example. Now, telnet would have its dependencies, and even though the telnet application is already downloaded and scanned and everything and exists here, it will have some dependencies that probably doesn't exist here. So your installation will fail, and then what will happen is you have to then get the dependencies. You speak to it's probably a different team that is managing this server. So you have to talk to that team, and then they will sort out those dependencies, make it available here, and then they scan it, sign it off, it's available, it's ready to go, and then you can install things. So there's a whole lot of overhead, but it's all down to security. Yes, so the cache server will still be getting updated from the internet because it has access to the internet. It can do whatever it's able to do from the internet, okay? But of course, it will have special type of configuration that anything that lands there gets scanned immediately. And if there's a virus, if there's anything that is a potential attack, it gets quarantined immediately, to deal with it, those kind of things, can happen. Okay. Or it could also be a case. Sorry.
Yeah, Darey, I was about to ask a question about we have the Bastion host there, which is connected to the internet gateway. Could all of these not be linked, like say the subnets not be linked or associated to that Bastion host, and then take advantage of the connection? Or you mean maybe the cache server that you put at the corner there is linked to that?
Let me try to understand the question. Are you saying that this Bastion could do the job of the cache server rather than have a separate server? Is that what you're saying?
Yeah, I'm just curious to see if cutting costs you could do that.
So it all depends on many things. If you have a cost that you want to save, where you feel like just use Bastion server to also serve as your cache server, everything has pros and cons, right? So it's always good to separate things. If you were going to be using Bastion server only for jump box, number one, it's going to be a tiny server that probably is using 2 gig of RAM and not a lot of storage, just enough to jump around, okay? And it probably doesn't require all the antivirus and all the other applications that will require on the cache server. Do you understand? So it may be a case where we just want to separate things. We know that this is our Bastion and we use it, dedicated it for that purpose. Okay. Cache server will have a different kind of management entirely. It's going to be a more strict environment where not everyone will have access to. Unlike Bastion, that you probably make it open to your engineers, your developers, and maybe even testers. But the cache server probably only needs to be accessed by the security team. So you can see why there's need for separation there. Okay.
Okay.
Then another thing that could be done,
Yeah, Darey.
rather than yes.
Yeah, me, I'm suggesting if an S3 bucket can, instead of configuring a server using an EC2 instance, maybe an S3 managed service can actually replace the cache server like an S3 bucket.
Yes.
If it's connected to a cloud
Yeah.
front, if that will work here.
So if you think about it, right, technically speaking, yes, you might be able to do that, and point your repository to download from S3, but are you going to be able to scan what you're downloading? Will S3 have the functionality to scan it as soon as it reaches the S3 bucket? Because you could have a server and mount your S3 path on the file system, okay? Or you still need a server, okay, that will be able to run antivirus and scan things for you. Do you understand? So
Yeah.
that's why I would use S3 for this kind of purpose. Okay. Even though it will work, yes, but always think about security, right? Then the other thing I was going to say is it's also possible to have this cache server in a separate subnet entirely. So you can have a subnet where this cache server is going to be. Okay, so imagine we have something like this. And these are hypothetical scenarios. So we have this, and it will be a separate okay, one second. So it's going to be a private subnet, okay, which will have its own root table and configuration to reach the internet through the NAT gateway. Okay, so all your other private subnets will not have that root table with routes to the NAT gateway. Only this subnet will have that root table that has the routing with the NAT gateway. So even though it's not in a public subnet like we did it previously, it's in a private subnet, but it's the only subnet that has access to the internet. So it's able to pull from the internet and do all of that. And then still, these guys will talk to it to download stuff. So you can be creative with your thinking, with your design. And this is where I was talking about if you are working as a solutions architect and you're designing a solution like this and you're proposing things, you want to do proof of concept and say, okay, will this work? Will that work? What makes more sense? You can read up online, blog posts on other people, how they're designing their infrastructure and things like that. But if you don't have hands-on experience being able to prove your concept, then how are you then able to successfully work as a solutions architect? Okay. So this is everything we've just talked about is just side discussions to tell you you can actually go as far or wide as you may think of. Okay. All right. So we were just about to create the root table for the private. So let's do that. So mcd private RTB root table. Okay. So we select the VPC mcd. And we create the root. So we've done that. So we've done number 8, create root table for the private subnet. So create a root in the creator root table and point it to the NAT gateway. So that's number 10. Okay. So edit root. So we can select the NAT gateway now. This is our NAT gateway. And then we can just save that. So now that we have this, we can now begin to associate our subnet. Okay, so we need to explicitly associate ourselves. We don't have anything explicitly associated. So the subnets that we want to be able to reach the internet will be this proxy and the compute. We don't need the data to do that because this is running Aurora. There's no EC2 instance that we can deploy in here. So there's no need at all to make this access the internet. Okay, so we can then edit that and then select our, let's say, MCD, so that we only have the MCD. So we're interested in the proxy 1 and 2, proxy 2, and then we don't need the data. So you see the reason why I had to name the subnet so that we can quickly see what we're looking for. So compute proxy, compute proxy. So these are the ones that we want to be able to reach the internet. So now we've subnet associations, we've now associated them. So any server we deploy here now will be able to download stuff and talk to the internet. Without this, you will do YOM updates, app updates, and it's just not going to work. Okay, so we've done number 9. So number 10, create a route in the creator route table on point. We've done number 10, associated private subnets, compute to the route table. So in the documentation, it says compute. So let's say compute, we do need for compute and proxy, compute and proxy. So I've updated that document. I'll update the note I sent to you as well. And then number 12 says create security group. So let's see. So it's past 10. I think we should stop at number 11 because from number 12, we'll start creating, different security groups. And that's where we'll not have to start thinking through what needs access to what. Okay, we'll tighten our security to ensure that we don't give access to everything. Before now on your previous projects, you would just open it all so that you can keep on working. But for a typical infrastructure like this, you want to make sure that you do not just open your network to everyone. So, for example, proxy needs to talk to compute. It doesn't need to talk to data. So there's no need to have a security group that allows it to talk here, basically. Okay, so we'll stop here today, and then next week we'll continue from here. However, I'll send you videos of this similar implementation that we've done everything end to end. So if you're able to watch that during the week and actually have ample understanding of how the whole thing connects together, then thumbs up to you. Makes it a lot more easy, so that even in class, if we're doing things, I may make a mistake, you can correct me, and then we can work together, basically. Okay. All right, so can we ask a question? With Aurora DB being AWS managed, how does the automatic update run if it's not routed to the internet gateway? So AWS takes care of that. Basically, we don't have to worry about things like that. When it's time to update the Aurora DB, it's just a matter of selecting the version that we want. Amazon makes it possible. They have packaged the application, they have scanned it, they've done all of that. It's available already in their own private. It's just like the cache server we talked about. So they already have it in their own cache environment where they can just take the update from. So it's nothing for us to think about. Okay, all right. So I'm going to stop sharing now. If we have any questions, let's talk about them now. Otherwise, we can say have a good night.
Yeah, Daddy, I got a question.
Cool.
First of all, I will like to announce to you and to our fellow brothers, that follow the program, that with regards to the interview, I came the last time and I asked a couple of questions related. I went in for a system admin role. You remember?
Yeah.
Where you advised me get in there, but don't stay for long, and stuff like that. Yeah, so I got it.
Oh, nice. Awesome.
Yeah, I got it. Yeah. So, and basically, like we spoke the last time, all my answers came from what we are doing here, the logic, the implementation that we learn here. Those are the things that I spoke about that made sense to them as well. So
Congrats.
it means,
I'm happy to
yeah,
hear
thank you
that.
so much. Yeah. Yeah,
Thank
it
you.
means really we should dedicate ourselves, and really what we are learning here is a lot. It's a lot, really. It gives you a lot of confidence in your interviews, because we don't have this opportunity. And really talking with an experienced person like Darey, that makes it easy, for you to ask some of your stupid questions, as well as, some of your doubts as well.
Yeah.
It's really good. It gives you the confidence, to do what you have to be doing. So I got it. Yeah, I have a question.
Okay.
It is strange. There they use OpenStack.
Okay.
Yeah, but when you come out with the logic, yeah, it goes in. It's just a bit strange that I've been creating some instances,
Yeah.
right, on OpenStack. I did like the installation, everything, and I created some instances on my private laptop, the one I use to do this course as well. It all works because I did the setup of the SSH connection,
Yeah.
so it's going. But with that of my company, I don't know, somehow it's not going. But when I pin the public IP, so they call it like the floating IP, right? When I pin it, it's working. But when I try to SSH, it's not going. It's not permitting me. I follow this all through, I think your video. But there are some things, since you use the company laptop, you can't change some permissions.
Yeah.
Yeah, and I can't. There we use like Chocolate,
Okay.
to download stuff. That one is a company Chocolate, so you can't download from the internet just like that, anything. Yeah, it makes it a bit difficult for me to configure the company laptop. And so I don't know. I've tried all the other ways. I have a Windows laptop.
Could it be a VPN? Are you supposed to connect to a VPN that's...
Yeah, but I checked, the VPN was on. And also my network was well, otherwise I won't be able to pin it.
So what's the error that you're getting? So when you try to SSH, if you do a ping, it sends the packet back.
Yes.
You can
Yes.
Or if you do SSH, what's the error you're getting back?
It says permission denied.
Ah, right. Okay. So the network is not a problem.
Yeah, network is not a problem. And also the security group is open.
Okay, that's fine.
SSH.
The fact that you're getting permission denied already eliminates network, so it can't be security group or anything like that. You're already talking to the server. It's just not happy with the way you're trying to connect. So it could be a number of things. First of all, check your, if you're using SSH keys, the private key that you're specifying, you need to check that. Okay.
Yeah, so I've even recreated a new one. I tried to follow some of some instruction, like you need to create some file for Windows. You need to put it on an authorized keys file, the public key. So I did the SSH key gen, and I copied the public key to that authorized key file.
Okay.
Yes. Yeah, and then the public key, that same public key, I actually used it to create my key pair.
Okay.
In the instance, just so that I could have like the key. I tried to do like the key pair where you do on Amazon, on AWS. then you download it and then try to log in from the folder where the key pairs are. I did it like that. It wasn't going, and there was like, let me try it this other way. So the key pair, actually, the public key that I SSH key gent created. So I use it but I upload it on the OpenStack. So I use it like my key pair on the instances that were created. So when I try to SSH that way as well, it still doesn't work.
So let me understand, how did you get the public key onto the server? Because if you can't connect, you're able to get it on there.
Yeah, thing is, I can create the instance. I can create the instance, right? But the connection I'm talking about is to connect to my laptop. So to open it from my command prompt.
Yes. So you
open the instance.
You provision the instance, right?
Yes.
And you specify the key that you intend to use to connect.
Yes. Yes.
Okay. You so do you get to download the private key when you're?
Yes. Yeah. Either you do that way, because there is like two options in OpenStack. You either can do that, you create a key pair, and then immediately you finish, it downloads.
Yes. Okay.
That's the way. So either you do that way. I did that way, and I put myself that is, I went on my command prompt, went to the folder where the key was downloaded, and then I did the SSH with like a door. I did the SSH command there, and it said permission denied. So I thought maybe I need to recreate an SSH key again. I did it all over, and then I uploaded my public key to the thing. I created a key pair with my public key, and I launched an instance, and I tried to connect. It still said the same. There was one instruction that I read, like I need to open a file SSH slash SSH config file, and then change on comment. I think SSH key should be yes, authorized SSH key should be yes, and then password should be as well yes. But I can't change based on the permission they gave me, they granted to me. I can't change that file. Every time I try to change it, it doesn't allow me to close the file, like write then close.
Yeah, Samuel is suggesting SSH.
Sorry, can I put up a suggestion?
I changed I tried to change mode. I tried to change the permission of the file where my public key is. Yeah, go ahead.
Yeah. What I feel is, if you are doing an SSH, if the key pair is in the wrong directory where you are not on, there must be a denial.
I was there. I was in the directory.
If you're in the directory where the key pair is downloaded, was saved.
Yes.
And it's still showing a denial, right?
Yes.
You may need to secure it.
Yes. There is a possibility if it is the key is too exposed, it might deny. So what I did was I gave a permission of only read on that one. So I gave, I think, chmod 644 on that one, just to read. But still, it still gave me the same. I just said I will bring it up here, maybe.
Okay. One of the ways I'm able to really troubleshoot things like this, the easiest way is if you were able to log on. And then you can check the logs on the server, because it reports the exact reason why it's telling you permission denied. Okay. It could also make maybe you're specifying a different user. So which username are you when you're trying to connect?
Yeah, that's the thing. The thing is, from what they told me those images that I'm using to create the instances, those images, if I'm using CentOS, for example, then it should be CentOS. If it's Ubuntu, it should be Ubuntu. Although I don't know where
Try
they
root. Try root.
Oh, yeah, that's something I didn't even try.
Yes, try root, because I'm thinking it will most likely be the name of the user that you're specifying.
That's
if
true.
it's not using the exact name of the user, you won't be able to access it. If it has to do with permission, the permission on the file, it will tell you that it's too open or something like that. So I don't think it's chmod. It will most likely be the name of the user. You need to get the exact name of the user that should be used, because I've found out sometimes, even in AWS, they tell you should use Ubuntu or something like that, but actually it's root that you're supposed to use. And the moment you do that, so you can try that.
Okay, I'll try. Hopefully that one can, because I've been like 2 days trying all these things. It's not going, and I don't want to go start asking them some very basic question of just an instance, something I do on my every second.
Yeah. Well, to be honest, I'll tell you what, sometimes you may feel like, oh, it's a basic, silly question, but trust me, it's not basic and silly. It depends on how you ask it. For example, you're saying, I need to SSH onto this server. I have done this, I've done that, I have done chmod, I've done all of this. None of them have worked. Okay, still I'm not able to log on to. They know you're not a novice because you know the things that you should have tried. And you've tried everything, you've highlighted everything now. No one is going to say you're asking a silly question.
Actually, I've brought it up. I brought it up in one conversation where my manager was about to give me the assignment to patch some servers. Yeah. So in that conversation, I told him, I don't know, I just gave the question to him whether he has done it before. Like, have you created an instance and tried to SSH on it? Because on mine, it's not going. I've really tried to do a lot of things. It's not going. With the limitation on access we have, there are certain things that I can't really change here. But on my private laptop, I can do it. So I don't know whether there's any heads up. He just found he hasn't done it before. And he doesn't want to stand that position now, to ridicule himself.
Yeah. Try that.
Yeah, I think that what you're saying is right. I think the root is the problem. Yeah, he needs to use the root.
Okay, I'll try with the root.
Because with what you've done, there's nothing that would have stopped it from SSHing.
Exactly.
Yeah.
There's nothing.
Okay.
If you're in the right directory and you have the right private key, I think the user is the only thing that will stop it from connecting. Yeah.
Okay. It's all right. I'll try it. At least that's one idea that can really take me out from the stress of repeating the same thing. I created already almost 30 instances and I deleted them. I tried all possible. I could not just imagine that. So for 1 million instances I created already, now I'm having, if this should be, my breakthrough. So this is why I'm done.
Wow.
Thank you so much.
No problem at all.
Yeah.
Okay. While we were talking, Yemi sent a message and he said he also got a job. I think he got a job and he has another offer or something like that. But he's in a noisy place. He won't be able to say that. So maybe next time he'll be able to share his news. So congratulations to you, Yemi. And for other people, because we have a number of people from previous batch that are also on this. And what we want to try and do is make this masterclass accessible to people, even though you've been on the previous batch before, because let's face it, this thing is not easy. So you just need continuous repetition of the same information and keep coming back. So that's why we decided to make it available to other people to start all over again. So for those who are from previous batch, as you're getting your job, please let others know so that they'll be encouraged. I get a lot of messages from a lot of people saying I'm frustrated, I'm pulling out my hair, this is not easy. You just have to, keep at it, and it will happen sometimes.
Yeah, that in my own case is I want my CV built. Yeah, I actually spoke to Solomon about it.
I thought that was done already.
It's not done. No.
Okay.
It's
All
not
right.
done.
Solomon, you're on the call, so please let's prioritize.
Yeah,
that.
I want my CV sorted out, man, so that I can start job hunting, man. I need to work.
No problem. No problem. All right then.
Thank you so much, man.
Much everyone, and I look forward to see you next weekend.
Mr. Darey, please.
Yes.
So the videos you'll be dropping the link on Slack channel, right? The videos you said we should watch over the week.
So for the ones that you watch during the week and the one we did yesterday and today, I'll send everything. So if you don't get it this night, don't worry. Tomorrow morning that'll be my first thing. I'll speak.
Thank you very much. Thank you very much.
All right. Thank you. Enjoy the rest of the evening. I'm off to bed myself, so you should do the same.
Thank you, sir.
All right then. Take care. Bye-bye.
Thank you. Bye.
Thank you.